All right, let's play a little mental game. Think about the car you drive today.
Okay.
Now, cast your mind back just 5 or 10 years. It's more than just a new model, isn't it?
Oh, absolutely. Huge difference.
It's a profound transformation happening sort of beneath the surface,
Hmm.
often without us even realizing it.
Yeah, the tech has just exploded.
Maybe the physical buttons are gone, replaced by sleek screens, sure.
Yeah.
But the real magic, the real revolution, it's in the invisible intelligence powering everything, quietly reshaping how we move, how we interact, and, well, how we experience the road.
That's a great way to put it.
Welcome, everyone, to the Deep Dive. Today, we're plunging headfirst into how artificial intelligence is absolutely revolutionizing the automotive industry.
It really is a transformation.
And let's be crystal clear from the get-go. This isn't just about self-driving cars. I mean, that's a huge part of it, obviously.
Definitely a big part.
But AI is fundamentally changing everything from the very earliest stages of how vehicles are designed and built
Right, from the drawing board.
to how they operate on the road, how they're maintained, and even how you, the customer, interact with dealerships and insurance companies.
The whole life cycle, really.
Our mission today is to cut through all the jargon and, the noise to give you a comprehensive understanding,
Yeah, get to the core of it.
to extract the most important nuggets of knowledge and insight from a stack of expert sources. Think of this as your shortcut to being truly well-informed about the future of transportation.
Like the highlights reel for automotive AI.
Exactly. The Blinkist level of concise, impactful knowledge. We're here to explore surprising facts, uncover unexpected connections, and inject just enough humor to keep you hooked on this incredible journey.
Sounds good.
We've pulled our insights from leading industry reports, cutting-edge tech companies, and AI pioneers like NetGuru, iTransition, Sapien, Salesforce, Altair, and of course, Waymo.
Some heavy hitters in there.
Definitely. These sources highlight the rapid advancements and the sheer breadth of AI's impact. They show us a future that's not just around the corner, but is, well, already taking shape on our roads and in our factories right now.
It's happening faster than many people think.
Whether you're a daily commuter, a tech enthusiast, maybe a future EV owner, or just insanely curious about what's coming next, understanding AI in automotive is absolutely crucial.
It affects everyone, really.
It's reshaping our roads, our cities, and our personal mobility as we speak. So what does all of this mean for you? Let's unpack this together.
Let's do it.
When we talk about AI in automotive, it's easy, almost instinctual, to leap straight to thoughts of autonomous vehicles.
Right.
Self-driving cars.
That's the headline grabber for sure.
But what our sources really reveal is a much, much wider revolution happening across the entire industry. We're not just talking about a cool new feature here.
No, it's deeper than that.
AI is enabling advanced driver assistance systems that almost act as a co-pilot, sophisticated predictive maintenance that saves you headaches.
And money.
And money, right. And deeply personalized in-car experiences that make your vehicle feel truly yours. Some of our sources even describe cars as becoming your personal assistant on wheels.
Which is quite a shift in perspective. It's not just transport anymore.
Exactly. And the impact truly stretches far beyond just what happens inside the vehicle or on the road. It's fundamentally reshaping manufacturing processes, making them faster and more precise.
We'll definitely get into that. The factory floor is changing dramatically.
It's optimizing supply chain management, ensuring parts get where they need to be. And yes, it's even changing how car companies market their products and how they interact with you, the customer.
Customer relationship management is getting a huge AI boost.
Ultimately, the big picture here is that AI is making cars safer, smarter, and more efficient in every possible way, driving a completely new era of transportation.
Zooming out a bit, what's truly fascinating is how pervasive AI's influence has become. It's no longer just an add-on, a gadget you might find in the premium package.
Right. It's not just for the luxury models anymore.
Exactly. It's foundational. It's transforming the very core identity of what a vehicle is and fundamentally altering how an automotive company operates.
So it changes the business model, too.
Absolutely. If we look at the broader implications, this really reflects a massive shift towards what we call software-defined vehicles.
Software-defined vehicles. Okay.
Think of it this way. Much like your smartphone's capabilities are largely defined by its software, right? Your car's future features, performance, and even its lifespan are increasingly determined by its intelligent software and AI systems.
Rather than just the metal and mechanics.
Precisely. Rather than solely its mechanical components. It's a fundamental change in how we think about what a car is.
And this isn't some distant, abstract concept from a sci-fi movie, is it?
Not at all. Many of these innovations are already actively impacting the vehicles you might be driving today or considering for your next purchase.
So like the safety features, the
Uh,
infotainment.
exactly. They're making cars inherently safer, more integrated into your digital life, and more responsive to your individual needs. And often, the AI is working so seamlessly in the background,
You barely notice it's there.
right, until it prevents an accident or suggests the perfect song.
Okay, here's where it gets really interesting, I think.
Yeah.
We're starting right at the very beginning of a car's life cycle, how it's designed and how it's actually made.
Back to the fundamentals.
AI is quietly yet powerfully revolutionizing everything from the factory floor to the high-tech design studio. It's making production faster, more precise, and frankly, just a lot smarter.
Efficiency and quality are the big drivers here.
Let's look at automated assembly and quality control first. On the factory floor, we're seeing AI-guided robots taking car assembly to a whole new level of speed and accuracy.
Fewer mistakes, faster production.
Right, drastically reducing mistakes. These aren't just your grandfather's programmed machines. They're intelligent robots that learn and improve over time,
Continual improvement built in.
boosting production outputs, while significantly reducing the heavy physical workloads traditionally placed on human operators. Think of them as incredibly skilled, tireless apprentices who get better with every car they touch.
Taking the strain off the human workforce, allowing them to focus on more complex tasks.
And for quality control, this is amazing. AI-powered computer vision systems are deployed to spot defects that even the most eagle-eyed human might miss.
Things invisible to the naked eye sometimes.
Exactly. This means far fewer faulty cars leaving the factory, translating directly into higher quality and greater reliability for you.
Which builds customer trust.
Our sources give a brilliant specific example from Audi. They've been using computer vision for years to inspect sheet metal components, catching even the tiniest cracks during production.
Proactive quality control.
More recently, they implemented AI-based quality control for spot welds and car body constructions at their Neckarsulm plant.
Now get this.
Okay.
The system analyzes approximately 1.5 million spot welds on 300 vehicles per shift. Wow. 1.5 million per shift. That's staggering.
Isn't it? To put that in perspective, manual ultrasound-based monitoring could only analyze about 5,000 spot welds per vehicle.
That's orders of magnitude difference.
The sheer benefit is clear. AI goes beyond simple rule-based anomaly detection. It identifies multiple types of defects and dramatically increases quality control efficiency.
Virtually eliminating the need for human intervention in this specific, crucial process.
It's like having a million microscopic eyes checking every single joint and griddle.
A huge leap in quality assurance.
Then we move into the realm of generative design and design simulation. This is where creativity meets computation.
Really exciting area.
Generative AI technology speeds up car design by rapidly creating hundreds, maybe thousands, of design variations for a specific component.
Based on parameters the engineers set?
Exactly, based on parameters set by engineers like weight, strength, material cost. This allows designers to explore vastly more ideas and optimize shapes and structures in a fraction of the time.
It augments the designer's creativity, doesn't just replace it.
That's a great point. Hyundai Motor Group, for example, actually used AI-driven generative design.
In partnership with Sunberg Ferrar, I believe.
Right, with Sunberg Ferrar, to create their ultimate mobility vehicle, Elevate. This isn't just a concept car, it's a truly unique vehicle.
The one that walks.
Yeah, it can transform from a four-wheel drive into a four-legged walking robot. It's intended for really challenging terrains, like search and rescue operations.
Amazing application.
David Byron, an industrial design manager there, aptly called it a mind multiplier. He said it lets designers see things they might not have otherwise even considered.
Pushing the boundaries of what's possible.
Truly pushing the boundaries of what a vehicle can be. And automakers are also harnessing digital twins.
Ah, yes, the virtual replicas.
Virtual copies of real vehicles. They use them to simulate how design decisions impact performance without having to build expensive physical prototypes every single time.
Saves massive amounts of time and money in development.
BMW, for instance, adopted this AI-based software called Monolith. They use it to predict a car's aerodynamic performance.
And crash safety, right.
Yes, and even the force on a passenger's tibia during a crash without conducting physical tests. And they do this much earlier in the development process.
So they catch potential issues way sooner.
Way sooner. This dramatically reduces the number of required physical simulations and tests, making existing data immensely more valuable. It's like having a crystal ball for engineering.
allowing them to fine-tune everything digitally.
Before a single piece of metal is cut, it's amazing.
That optimization flows through the whole process.
And this intelligent oversight extends to the manufacturing equipment itself. Imagine this. IoT sensors those tiny internet-connected devices.
On everything from robots to conveyors.
Right. They gather data from machinery parts and feed it into machine learning-based systems. These systems then detect anomalies and alert employees about potential failures before they happen.
Predictive maintenance, not just reactive.
Exactly. It's a fundamental shift from traditional scheduled maintenance, where you fix things on a calendar, to truly predictive maintenance,
Fixing things just before they break, ideally.
cutting repair costs and minimizing that dreaded equipment downtime. It's all about keeping the production lines humming smoothly, avoiding costly, unexpected stoppages.
Maximizing uptime and throughput.
Finally, AI is absolutely optimizing production scheduling and supply chain management. This is huge.
Especially in today's complex global supply chains.
Definitely. AI-powered solutions are incredibly adept at predicting product demand based on complex factors like economic conditions, industry trends, even seasonal changes.
Allowing manufacturers to adjust output.
Right, and manage inventory with remarkable precision. Beyond that, AI systems analyze real-time information on shipments, market trends, social media chatter,
Even weather forecasts.
even localized weather reports, yeah, to refine production planning and product distribution. This makes supply chains incredibly more efficient, resilient, and cost-effective.
More adaptable to disruption.
Altair, for example, has pioneered a solution leveraging AI and machine learning to optimize inventory challenges, specifically for something called safety stock calculations.
Which is basically how much extra inventory you keep on hand.
Exactly. They move from relying on experience-based assumptions, gut feelings, essentially to using predictive and prescriptive analytics,
Data-driven decisions.
which actually recommend optimal order quantities and automate that entire process. This solution also helped Jaguar Land Rover automatically categorize warranty issues with over 90% accuracy,
Wow, 90% plus.
assigning them to the correct engineering teams, which significantly improved warranty cost savings and accelerated problem identification. It's a massive leap in operational intelligence.
Finding the root cause faster.
You know, if we connect all this to the bigger picture, this relentless drive for efficiency and precision through AI, it translates directly into the quality and the ultimate cost of the vehicles you eventually see on the road.
Better cars, potentially more affordable cars.
It fundamentally means cars are built better, with far fewer defects, and can potentially be brought to market faster and more affordably because the entire process from concept to assembly is streamlined and intelligently optimized.
It really makes you wonder, doesn't it? How much of our everyday perception of a car's inherent build quality, that solid feel, the smooth operation,
Yeah, that feeling of solidity.
is now thanks to these unseen, highly sophisticated AI systems diligently working behind the scenes. It's truly a foundational change that benefits the end user tremendously.
And these advancements mean you are getting higher quality, more reliably built vehicles right out of the gate.
Less chance of early problems.
Plus, and this is crucial, the parts needed for any future repairs are more likely to be readily available due thanks to these incredibly optimized supply chains.
Which minimizes those frustrating delays at the garage.
Exactly, ensuring your vehicle can be serviced efficiently when it needs it most.
That whole ecosystem is becoming smarter.
So, what does this all mean for you personally? Beyond the factory, AI is taking on another monumental role, making the very act of driving itself incredibly safer.
Which is probably the benefit most people think of first.
I think so, making it safer for you and everyone else on the road. Let's dive into advanced driver assistance systems, or ADAS.
8As, yeah. Becoming very common.
These systems are basically your car's super smart guardian angel, using AI to help drivers avoid crashes by processing data from a multitude of sensors and cameras in real time.
Constantly scanning the environment.
We're talking about features like lane departure warnings that gently nudge you back into your lane if you drift,
That little vibration in the steering wheel.
adaptive cruise control that automatically adjusts your speed to maintain a safe distance from the car ahead in traffic,
Makes stop-and-go traffic much less stressful.
and even clever parking assistance that takes the guesswork out of tricky spots. Add to that traffic sign recognition, forward collision warnings that alert you to potential impacts,
Beeping or flashing lights.
and even drowsiness detection to make sure you're staying alert behind the wheel. The core benefit here is undeniable. These systems react faster than any human possibly could,
That reaction time is key.
spotting potential dangers and providing better vehicle control even in challenging conditions like poor visibility, thus significantly minimizing accident risks. They're like having an extra pair of eyes and an extra brain dedicated purely to safety.
A very focused co-pilot.
This leads directly into automatic braking and accident prevention. AI-powered automatic braking systems use those same sophisticated sensors to detect objects or vehicles ahead,
Cars, pedestrians, cyclists.
and can apply brakes much faster and more forcefully than most human drivers if a collision is likely. The impact of this technology is genuinely significant.
The data backs this up.
Studies have shown it can reduce rear-end crashes by about 50%, which is particularly useful for preventing accidents caused by distracted driving, something we've all probably been guilty of at some point.
That momentary glance at the phone.
Exactly. And some even more advanced systems can even subtly steer the car to help avoid obstacles, providing an additional vital layer of protection when every millisecond counts.
Evasive steering assist, yeah.
And then we have driver monitoring systems, which are becoming incredibly sophisticated and personalized.
Looking inside the car now, not just outside.
Right. AI cameras and sensors strategically placed inside the car track driver behavior, looking for telltale signs of drowsiness, distraction, or even impairment.
Head position, eye movement.
If risky behavior is detected, the system doesn't just sit idly by. It actively alerts the driver. Some advanced cars can even take proactive measures,
Like slowing down.
slowing down or even pulling over to a safe spot if the driver doesn't respond to repeated warnings. The primary purpose of this technology is crystal clear: to prevent accidents caused by human error.
Which is still the leading cause of crashes.
Unfortunately, yes. It remains the leading cause of collisions globally. It can also be cleverly used to coach drivers on safer habits over time, encouraging better driving practices for everyone.
Like a gentle, persistent driving instructor built into the car.
Exactly, like a nudge towards better driving.
What's truly fascinating here is how AI functions as a continuous co-pilot, an ever-vigilant presence in ways a human driver simply cannot be.
Always on, never distracted.
Right. It's essentially a non-stop layer of risk assessment, operating with sub-millisecond precision. If we connect this to the bigger picture, it fundamentally redefines safe driving from solely human responsibility
Do a partnership.
to a dynamic and incredibly intelligent partnership with these sophisticated systems. It's not just about replacing human capability, it's about profoundly augmenting it.
Creating a much stronger safety net.
A far more robust and proactive safety net that reduces the margin for human error significantly.
And critically, these aren't just exclusive luxury features anymore, are they?
No, not at all. 80 systems are rapidly becoming standard in many new vehicles across various price points.
Which is great news for everyone.
Absolutely. This directly contributes to your safety and the safety of countless others on the road, making every journey inherently less risky and more reassuring than it would have been just a decade ago.
Okay, let's unpack this. For many of us, the ultimate pinnacle of AI in automotive is the long-held dream of self-driving cars.
The future we've seen in movies for decades.
Exactly. This is where AI truly becomes the brain of the vehicle, orchestrating every single aspect of the driving experience, ideally without any human input at all.
The Holy Grail, as they say.
First, let's understand the emergence and different levels of autonomy. Self-driving cars use AI to navigate without human input, relying on a complex array of sensors, cameras, and powerful onboard computers.
A whole suite of technologies working together.
The Society of Automotive Engineers, or SAE, has helpfully classified autonomy into 6 distinct levels. We start at level 1-2, which is basic driver assist, think adaptive cruise control.
Hands on the wheel, eyes on the road still.
Right, where a human driver is still required to pay full attention. Then we progress to level 3-4, where vehicles can operate independently under certain specific conditions.
Like highway driving, maybe?
But human oversight is still possible and sometimes required to take over. And finally, the big one, level 5.
Full autonomy. Anywhere, anytime.
Fully autonomous driving in all conditions, with absolutely no human input required at all. Companies like Tesla, with its autopilot.
Which is technically level 2, but advancing.
Right, good point. Waymo, with its pioneering robotaxis operating in certain cities.
Phoenix, San Francisco.
And Cruise, backed by GM and testing extensively in places like San Francisco, are truly at the forefront of this revolution.
Pushing the boundaries constantly.
Waymo, for instance, famously refers to its technology as the world's most experienced driver.
Bold claim, but backed by data.
They boast millions of miles on public roads and literally billions more in simulation. They emphasize that it never gets drunk, tired, or distracted, and passengers don't even need to know how to drive.
That's a profound statement about the future of personal mobility. Changes everything.
So how do these vehicles actually see and think? What are the key AI technologies powering this autonomy?
Let's break down the tech stack.
First up is computer vision and object detection. AI-driven vision systems use deep convolutional neural networks, or CNNs.
Think of them as pattern recognizers.
Yeah, like digital eyes that learn to spot patterns and identify objects with incredible accuracy, much like a child learning to recognize different animals or objects. These CNNs are trained to accurately detect and interpret everything around the car.
Pedestrians, vehicles, signs, lanes.
Everything in real time. This is absolutely crucial for recognizing hazards and navigating incredibly complex, often unpredictable traffic scenarios.
Seeing and understanding the world.
Then we have LiDAR and radar, two complementary sensor technologies. These help self-driving cars see in 3D, especially when cameras are challenged by poor lighting or weather.
Cameras struggle in fog or darkness.
Exactly. LiDAR, which stands for light detection and ranging, uses millions of tiny laser pulses sent out in all directions,
Measuring the reflections.
measuring how long they take to bounce back. This creates an incredibly detailed, high-definition 3D map of the car's surroundings with remarkable precision. Newer, cheaper versions are constantly increasing its adoption.
LiDAR costs used to be a major barrier.
Radar, on the other hand, uses radio waves to detect objects and works particularly well in adverse weather conditions like heavy rain, fog, or snow, where lasers can be obstructed.
Cuts right through the soup.
Recent advances have made radar much more accurate and discerning. Autonomous vehicles then employ a technique called sensor fusion.
Combining all the inputs.
Exactly. It's essentially combining and cross-referencing all this diverse data from LiDAR, radar, ultrasonic sensors, and cameras. This creates a comprehensive, virtually infallible 360-degree perception of their surroundings,
More reliable than any single sensor.
dramatically enhancing navigation accuracy and obstacle detection. It's like having multiple pairs of highly specialized eyes and brains constantly collaborating and validating information.
Building a robust world model.
At the core of all this are machine learning and deep learning. These are the powerful algorithms that allow autonomous vehicles to continuously improve,
Learning from experience.
improving their driving accuracy, responsiveness, object recognition, and complex scene interpretation. They enable predictive analytics,
Anticipating what happens next.
which is the system's ability to anticipate what other road users might do, like a pedestrian suddenly stepping off a curb or a car swerving, reducing response time and improving overall safety by constantly learning from vast amounts of real-world data and those billions of miles in simulations.
Learning subtle cues and patterns.
And to ensure instantaneous reaction times, which are absolutely critical for accident prevention, we have Edge AI.
Processing on board the vehicle.
Right. This means the AI processes data locally, right there within the vehicle, minimizing reliance on cloud computing and significantly reducing any potential communication latency. It's about thinking on its feet, in real time.
No delays when a split-second decision matters.
Let's use Waymo as a great example to understand how autonomous cars think through a scenario. Their process can be broken down into 4 key steps. It all starts with incredibly detailed mapping.
High-definition maps are crucial.
Before operating in any area, Waymo maps it with painstaking precision, noting every lane marker, every stop sign, curbs, crosswalks, even individual trees and streetlights.
Much more detailed than consumer GPS maps.
Oh yeah. The Waymo driver then uses these custom high-definition maps, matched with its real-time sensor data and AI, to determine its exact road location at all times.
Pinpoint accuracy.
Never solely relying on external data like GPS, which can sometimes lose signal strength or be less precise.
GPS alone isn't enough for autonomy.
Next is perception. The system deciphers complex data streams from its advanced sensors, identifying everything from pedestrians and cyclists to other vehicles, construction zones,
And reading traffic lights and signs.
and responding instantly to signs and signals, including the subtle color changes of traffic lights. Then comes prediction, leveraging its vast experience.
That 20 million miles real world, 20 billion simulated.
Exactly. The AI anticipates what other road users might do. It understands the different behaviors of a car versus a cyclist versus a pedestrian and can predict multiple possible paths and intentions in milliseconds, constantly evaluating probabilities.
What's the most likely action of everything around it?
Finally, planning. Based on all this input, the detailed maps, the real-time object perception, and those predictive analyses, the AI plans the safest, most efficient action,
Path planning.
determining the exact trajectory, speed, lane changes, and steering maneuvers needed to get to its destination smoothly and safely.
A continuous cycle. Map, perceive, predict, plan.
This technology then undergoes truly rigorous testing to ensure reliability and safety. Waymo, for instance, tests its software on closed courses,
Controlled environments.
staging over 40,000 unique, complex, and rare scenarios in safe, controlled environments that would be too dangerous to test on public roads first.
Recreating edge cases safely.
They also conduct constant driving on public roads to evaluate and improve performance in real-world, unpredictable situations.
Gathering that invaluable real-world data.
And in simulation, they've driven over 20 billion miles, constantly replaying and tweaking real-world miles or creating new virtual scenarios for continuous practice.
Testing variations endlessly.
They conduct thousands of specific crash avoidance tests, meticulously recreating distinct driving situations like vehicles pulling out suddenly, motorcyclists weaving, or jaywalking pedestrians to analyze the driver's response and refine its behavior.
Making sure it handles the unexpected.
There's also comprehensive hazard analysis and reliability and durability testing. Individual components are exposed to extreme conditions.
Like heat, cold, vibration, water.
Powerful UV radiation, high-pressure water jets, corrosive salty mist, constant vibrations, and extreme temperatures for weeks on end, all to identify any weaknesses and ensure lifetime performance. It's an exhaustive, unrelenting pursuit of perfection.
Building robustness into the hardware and software.
Finally, for safety, the Waymo driver is designed with multiple overlapping layers of redundancy. Think of it as a technological fail-safe upon fail-safe.
Belt and suspenders approach.
Definitely. It has a secondary onboard computer constantly running in the background, independent backup collision detection and avoidance systems, redundant steering with secondary motors,
A full secondary braking system.
independent power sources for critical systems, and redundant inertial measurement systems for precise vehicle positioning, even if primary sensors are momentarily compromised.
Multiple ways to stay safe if something fails.
Plus, robust cybersecurity processes are deeply embedded to identify, prioritize, and mitigate cyber threats, aligning with the highest industry best practices. It's truly a fortress of safety measures designed to handle nearly anything.
Security is absolutely paramount.
It makes you wonder, doesn't it? The progression from basic driver assistance to full autonomy is less about one big sudden aha moment,
No single breakthrough.
and much more about the incremental, rigorous integration of these incredibly sophisticated AI systems and the massive data processing that underpins them.
It's painstaking engineering and validation.
The sheer scale of data curation and validation, as powerfully exemplified by Waymo's billions of simulated miles, is absolutely immense. And it's precisely this painstaking, continuous cycle of learning and refining that truly builds the foundation of trust for these vehicles.
Rather than a single technological leap, it's earned trust through data and testing.
The progress we're seeing in self-driving cars is a monumental testament to AI's transformative power. We're truly moving from what once felt like pure science fiction
Something on the distant horizon.
to a near reality, promising a future of potentially safer and significantly more efficient travel for you, whether you're commuting to work or just taking a leisurely drive across the country.
The potential benefits are enormous.
So what does this all mean for your everyday drive? AI isn't just about getting from A to B safely. It's also about making the journey easier, more personal, and even, dare I say, more enjoyable.
Improving the cabin experience.
Let's talk about the personalized in-car experience, which is becoming incredibly advanced. Voice recognition and connectivity are huge.
Talking to your car is becoming normal.
Voice assistants, whether they're third-party like Alexa or Siri, or proprietary solutions built right into your car, make it incredibly easy to control features hands-free.
Adjusting temperature, music, navigation.
Playing your favorite music, making calls, getting directions, all with simple voice commands. And here's the clever part. Machine learning helps these systems understand a huge variety of accents and speech patterns
Getting better and more accurate over time.
with every interaction. Then there's customized entertainment. Machine learning algorithms power in-car entertainment systems that actually learn your preferences,
Suggesting music, podcasts.
suggesting music, podcasts, or audiobooks based on your past choices, current driving conditions, and even potentially your mood, which some systems can infer via in-car cameras.
Mood-based playlists. Interesting.
Playlists can even be dynamically curated to match your trip length, creating the perfect soundtrack for your journey. And for personal settings,
Seat position, mirrors.
cars are getting smart enough to learn owner preferences and automatically adjust things like seat positions, mirror angles, and climate control settings based on who is driving.
Creating an instantly familiar and comfortable environment the moment you step in. Like the car knows you.
Exactly. Navigational systems are also radically improved by predictive analytics. Forget just knowing the fastest route.
It's more than just shortest time now.
Smart navigation systems now use machine learning to find the absolute best routes by analyzing real-time traffic data, current road conditions, and even your past trips.
Helping drivers avoid jams and get to destinations faster and more predictably.
They don't just react to traffic. They predict patterns, suggest alternate routes in real time, and even learn your favorite places and typical routines.
It anticipates your needs.
Tesla's Trip Planner, for example, features an AI-powered system that automatically calculates the fastest route, factoring in your specific driving style, the outside temperature, live traffic conditions.
And crucial for EVs, energy consumption.
Yes. Crucially, it smartly considers the location and availability of Tesla superchargers, helping you minimize queues and optimize charging times.
Making those EV road trips incredibly seamless and stress-free. Takes the range anxiety away.
Speaking of EVs, AI plays a surprisingly significant role in electric vehicle integration, making them even more efficient and user-friendly.
Optimizing battery performance and charging.
Smart energy management systems in EVs predict your energy needs for a trip, dynamically learn from your driving habits to adjust power use,
Squeezing out extra miles.
and can even find optimal charging times based on fluctuating electricity rates to save you money. AI also enhances EV performance,
Adjusting handle.
subtly adjusting how the car handles based on road conditions for a smoother, safer ride. It optimizes power use for your common roads to help the car go farther on a single charge.
Learning your commute to maximize range.
And at a broader infrastructure level, AI can be used to efficiently allocate and strategically build charging stations.
Ensuring proper coverage and reducing range anxiety for all EV owners. That's a big one.
Solving a critical infrastructure challenge for the wider adoption of electric vehicles.
It's not just the car, it's the whole support system.
Beyond individual drivers, AI is absolutely revolutionizing intelligent fleet management solutions for businesses.
Delivery companies, logistics, ride sharing.
For fleets, predictive maintenance with AI is a genuine game changer. AI-powered systems analyze vast amounts of data from sensors across an entire fleet and historical repair records.
Predicting failures before they happen.
Exactly. Predicting exactly when parts might fail. This allows fleet managers to schedule fixes proactively, preventing costly breakdowns, cutting repair costs, and minimizing vehicle downtime.
Keeping vehicles on the road, making money.
Some incredibly advanced systems can even automatically order the necessary parts. AI also optimizes fuel efficiency and logistics for entire fleets.
Route optimization is huge for fuel savings.
It helps companies significantly reduce fuel consumption and plan better routes by considering real-time traffic, dynamic weather conditions, and precise delivery schedules. It can even track individual driver behavior,
Spotting inefficient driving habits.
spotting habits that waste gas, leading to targeted coaching opportunities, and, for some fleets, up to a remarkable 15% reduction in fuel costs.
15%. That adds up fast across a fleet.
And the use of digital twins, those virtual copies, extends to fleet operations too. Managers can test new routes or maintenance plans safely on a computer.
Without risking real assets or operations.
This helps them make smarter, data-driven choices about buying and using vehicles, boosting overall fleet productivity by over 20%.
Significant gains in efficiency.
It's truly fascinating, isn't it? How many layers of AI are tirelessly working in the background to make things smoother, more efficient, and incredibly optimized.
Even if you don't consciously realize it's happening.
From helping you find your perfect song for your commute, to ensuring a critical delivery arrives precisely on time, AI is orchestrating a personalized and highly optimized experience behind the scenes.
It makes you wonder, as cars become more and more like truly intelligent personal assistants, continuously learning and adapting,
How will our fundamental relationship with them evolve?
beyond just mere transportation. It's no longer just a piece of machinery. It's becoming a highly integrated, responsive companion in our daily lives.
A companion. That's an interesting way to think about it.
Ultimately, these pervasive AI enhancements are all designed to make your driving experience more convenient, more customized, and significantly more stress-free.
Whether you're navigating the chaos of rush hour traffic, embarking on a long road trip, or simply enjoying your favorite music on a short journey.
It's about a seamless, intuitive interaction, making life easier.
And it's not just the cars themselves, which are undoubtedly brilliant. It's the whole ecosystem surrounding them. AI is also deeply transforming how car companies, dealerships, and even insurance providers interact with you, the customer.
The entire customer journey is being touched by AI.
Think about AI-driven customer interaction platforms. AI-powered chatbots are now widely used by car brands and dealerships.
Answering common questions 204/7.
Right? Answering questions about cars, pricing, features, even scheduling test drives or service appointments, all available 24/7. These aren't just simple rule-based bots.
Learn and improve.
They learn and improve with each conversation, becoming more helpful and nuanced over time. AI also significantly boosts companies' social media responsiveness,
Handling the sheer volume of online comments.
enabling them to quickly process and respond to thousands of comments, spotting urgent issues, and intelligently alerting human staff when a more personal touch is needed.
Filtering the noise. Finding the critical issues.
This seamlessly feeds into personalization and marketing automation. AI analyzes vast amounts of customer data, your browsing history, past purchases, even your engagement with social media,
Building a profile of your interests.
to deliver incredibly personalized advertisements and promotions for cars they believe you might genuinely want. We're talking smart email marketing,
Tailored offers, not generic blasts.
where AI sends different emails to different people based on their specific interests. For example, a sports car enthusiast might receive tailored offers for high-performance models.
While a family looking for space might get promotions for SUVs. Makes sense.
Critically, AI also optimizes timing, predicting when a customer is most likely to be in the market for a new car,
Reaching you at the right moment.
enabling brands to send the right message at the right time, maximizing its impact. It's quite sophisticated.
Moving beyond guesswork in marketing.
AI also significantly enhances vehicle diagnostics for customers. Imagine AI and predictive analytics constantly gathering data on your vehicle's operation and usage.
Like a built-in health monitor.
Through smart sensors, diagnostic systems can detect even subtle anomalous conditions and proactively alert you, the driver, about potential technical issues.
Enabling timely servicing before a small problem gets big.
Exactly. Before a small, inexpensive problem escalates into a major, costly one. It's like having a mechanic permanently under your hood, whispering warnings.
That's a nice peace of mind feature.
And for the insurance sector, AI is making significant waves in both vehicle damage assessment and fraud detection.
Streamlining the claims process.
For damage assessment, some insurance companies are now leveraging AI and computer vision to automate parts of the vehicle inspection process. Drivers can simply take photos of damaged cars with their smartphone,
And the AI assesses the damage.
and an AI-powered system analyzes them to quickly and objectively evaluate the extent of the damage, making the claims process significantly faster and often more transparent.
Faster payouts, less hassle.
In terms of fraud detection, sophisticated machine learning systems use natural language processing to spot inconsistencies or suspicious patterns in insurance claims,
Looking for red flags in the claim description.
flagging potential fraud for human review. Predictive analytics further help insurers estimate fraud risk based on policyholder profiles,
Which can lead to more accurate premium calculations.
ultimately benefiting honest policyholders with potentially fairer premiums.
That's the goal anyway.
If we connect all of this to the bigger picture, AI is fundamentally shifting the customer relationship in the automotive industry from being merely reactive and transactional
Responding only when something goes wrong.
to being proactive, deeply personalized, and far more efficient. This raises a crucial question for all of us as consumers.
The balancing act.
As these systems get increasingly smarter and more ingrained in our interactions, how will we collectively balance the incredible benefits of efficiency and personalization with legitimate concerns about data privacy and the transparency of these powerful decision-making algorithms?
It's a delicate but absolutely crucial balance we need to strike going forward. Where's the line?
Ultimately, what this means for you is that AI is making your entire experience with car manufacturers, dealerships, and even insurance providers more streamlined, more personalized, and significantly more efficient.
Helping you find the right car that perfectly fits your needs, receive better, more proactive service, and navigate complex processes much more smoothly, easier all around.
But of course, with such profoundly transformative technology, comes equally great complexity and significant hurdles.
It's not all smooth sailing. There are big challenges.
AI in automotive faces considerable challenges before it achieves full widespread adoption across the globe. It's important for us to understand these.
We need to be realistic about the
One
roadblocks.
of the primary key challenges is integration. AI solutions often have multi-layered architectures with a complex web of interconnected components.
Sensors, software, cloud platforms.
Everything from IoT sensors on a car to massive data analytics software in the cloud, and these components often rely on different communication protocols.
They don't always speak the same language.
If these don't talk to each other seamlessly, it can lead to information silos and unreliable analyses, like trying to have a conversation where everyone speaks a different language.
Garbage in, garbage out, potentially.
To address this, companies need sophisticated data superhighways, often called ETL or ELT pipelines, for smooth data integration. They also need robust APIs.
Like universal translators.
Yes, for seamless data exchange and middleware architectures, sometimes using techniques like data virtualization to handle those incompatible protocols and ensure everything works together harmoniously.
Making disparate systems cooperate.
Another major hurdle is connectivity. Many advanced AI use cases, such as real-time route optimization for autonomous vehicles or instant fleet management updates,
Need constant, reliable connection.
require incredibly stable and high bandwidth networks for instantaneous data exchange. This can be incredibly difficult to maintain with sudden load spikes or in geographical blind spots like tunnels or remote areas,
Dropped signals can be critical.
causing high latency, meaning delays, and potentially inaccurate or outdated analytics. Recommendations here include deploying what we call loosely coupled IoT sensors.
That can store data locally if needed.
Exactly. Intelligently store data offline if needed. Adopting edge computing to process data locally within the vehicle itself, significantly reducing network dependency.
Less reliance on the cloud for critical functions.
And using bandwidth-efficient communication protocols like MQTT, which are designed to send information efficiently, even over unreliable networks.
Getting the most out of the available bandwidth.
Then there's the monumental task of data analysis. Processing the truly massive data sets these systems generate and handling real-time data streams requires absolutely significant computing resources
Which costs money and energy.
and can be costly. Furthermore, machine learning algorithms need colossal, high-quality training data sets to learn effectively. And even then, models can suffer from overfitting.
Where it works great on training data, but fails in the real world.
Right. Or model drift, where its performance gradually degrades over time due to changing real-world conditions.
The model gets stale.
Solutions involve complementing existing resources with scalable cloud-based AML services, like Amazon SageMaker or Azure Machine Learning,
Leveraging cloud computing power.
implementing masterless cluster architectures, which means systems that can dynamically scale their computing power to handle fluctuating demands, and rigorously splitting data into training, validation, and test sets to prevent overfitting.
Careful data management is key.
Crucially, they also need to constantly monitor for model drift and regularly retrain those models with fresh data to keep them sharp.
Continuous learning and updating.
Data privacy and security are also paramount concerns, especially as cars become mobile data centers.
Collecting huge amounts of potentially sensitive data.
Increased data volumes mean inherently higher security risks, ranging from the dramatic potential for car hacking to the more subtle threat of intellectual property leakage. Much of the data collected.
Video location data.
Think video footage from cameras. Precise geolocation is intensely personal and therefore subject to stringent regulations like GDPR in Europe.
Compliance is non-negotiable.
Companies absolutely must process data in line with these regulations, train models with obfuscated data, meaning anonymized or encrypted data whenever possible,
Protecting individual privacy.
and implement robust security measures like cryptographic key management, dynamic data masking, and multi-factor device authentication to protect against breaches.
Building strong digital defenses.
Beyond these, there remain significant technical barriers that still need addressing before full Level 5 autonomy is commonplace.
We're not quite there yet.
This includes the need for ever higher performance computing that can handle unprecedented amounts of data, the continuous acquisition of even more extensive, diverse, real-world training data from every conceivable driving scenario,
Capturing all the edge cases.
and critically, improving sensor reliability in truly adverse weather conditions like heavy rain, dense fog, or thick snow, which can still challenge even the most advanced vision and LiDAR systems.
Making sensors robust in all conditions.
Then we have the complex web of regulatory and legal considerations. Unresolved questions regarding liability in accidents involving self-driving cars are paramount.
Who is responsible when an autonomous car crashes?
Who is truly at fault? The human safety driver, the manufacturer, the software developer, or perhaps even the vehicle owner? Also, government policies and safety requirements vary significantly across different regions and countries,
Creating a complex patchwork of rules.
which complicates global development and deployment of autonomous vehicles. It's a legal minefield that needs careful navigation.
Standardization would help, but it's difficult.
Finally, public trust and adoption are absolutely crucial. User skepticism about the safety of autonomous vehicles, often amplified by rare but high-profile incidents,
One bad accident gets a lot of attention.
and the persistent vulnerability to hacking and cyber threats continue to hinder widespread public acceptance. People need to feel genuinely safe and secure in these new machines before they fully embrace them.
Building that trust takes time and transparency.
To actively address these manifold concerns, the industry is pursuing several strategic approaches. This includes advocating for radical transparency about AI algorithms and their decision-making processes,
Explaining how the AI works.
implementing extremely strict data privacy measures, collecting only absolutely necessary data, and providing clear information on data usage with individual control.
Giving users control over their data.
Developing and rigorously adhering to robust ethical guidelines that outline the clear responsibilities of manufacturers, operators, and regulators.
Establishing rules of the road for AI development.
Ensuring incredibly rigorous testing and regulation by government agencies before any public deployment, and fostering intense collaboration between industry players, government bodies, and other stakeholders
Working together to find solutions.
to ensure that effective, safe, and widely accepted solutions are brought to market responsibly.
It has to be a collaborative effort.
Looking to the future, the industry is unequivocally moving towards the concept of software on wheels, where vehicles receive frequent, comprehensive, over-the-air updates.
Much like your smartphone gets updates.
Exactly, gaining new features and improved performance throughout the car's life. Enhanced capabilities will come through the tighter, seamless integration of AI with cutting-edge 5G technology and the rapidly developing smart city infrastructures,
Cars talking to each other and the city around them.
and the continued innovation by AI pioneers will relentlessly push us towards fully autonomous, incredibly efficient, and ultimately far safer transportation systems that redefine how we experience mobility.
The potential is still enormous.
All of this makes you truly ponder, doesn't it?
Yeah.
As AI continues to become the fundamental driving force behind this monumental automotive transformation.
The focus shifts.
The focus will undoubtedly shift from the initial question of can we do it to the far more profound how do we do it responsibly, ethically, and equitably.
That's the critical question now.
Balancing this incredible pace of innovation with these critical challenges, from security and privacy to legal liability and public trust, will absolutely define the next decade of mobility.
And ultimately determine how seamlessly these groundbreaking technologies integrate into our daily lives. Getting it right is crucial.
While the future of AI in automotive is undeniably incredibly promising, understanding these deep-seated challenges allows you to genuinely appreciate the immense complexity involved
It's not easy.
and the crucial work that is still being done right now to ensure these groundbreaking technologies are truly safe, secure, and reliably beneficial for everyone.
A lot of smart people are working on these problems.
We've truly taken a deep dive today into the incredible transformative world of AI in automotive. From revolutionizing the very way cars are designed and manufactured with generative AI and digital twins,
All the way from the factory.
to making our roads dramatically safer with advanced driver assistance systems and increasingly sophisticated autonomous capabilities.
To the driving experience itself.
And even personalizing your in-car experience and streamlining how you interact with dealerships and insurance providers. AI is undeniably the invisible, yet incredibly powerful intelligence powering the automotive industry's complete transformation.
It touches almost every aspect.
The car of tomorrow isn't some distant sci-fi dream. It's genuinely here, evolving at breakneck speed, powered by this amazing adaptive intelligence.
It's an exciting time.
It promises not just unparalleled convenience, but a future with statistically fewer accidents, less frustrating congestion, and a much more efficient use of resources for all of us, a genuinely exciting prospect.
Safer, cleaner, more efficient mobility.
So as cars become more and more like intelligent partners, making complex, real-time decisions on our behalf, consider this.
Oh, final thought.
How much of our daily lives, far beyond just the act of driving, will ultimately be shaped by the autonomous decisions of AI? What new possibilities, or even what new dilemmas might that bring for all of us as a society?
It's a truly fascinating future to ponder, and one we're only just beginning to navigate. Lots to think about.